All right. So once again, this is for the video, but Roman numerals charges can vary, so we have to give you what their charges are in parentheses. So that's where that +2 came from. This system, or this process, is very systematic. You want to write the symbol, and I'm going to write everything down here just because I have more room. The symbol of all the stuff, the charges of all the stuff, and then you do what we call the drop and swap. So lead is Pb, and its charge is +2 because we said so right here. The Roman numeral tells me. And then acetate, I should have it memorized, but if you don't, it's on the screen right over there. So acetate is C2H3O2, and then its charge, once again, is something you should have memorized. It's a -1. All right, so once we have all the stuff and all the charges, we just double check. Does this right here equal 0? No, so I have to drop and swap. I need to take this 2 and put it over here. But I don't have 22 oxygens, so I need to make sure I put parentheses in and have the number on the outside. And if we look real quick, we'll prove it like in math where you do proofs. All right, we need 2 -1s. So 2 times -1 equals -2, correct? Plus 1 plus 2. So 1 times 2 equals 2. Does that equal 0? You bet it does. So we know we have this correct. Next up is barium hydroxide. Most people, as I looked around, had this right, or they had it really close to right. They made all the same. All of you made pretty much the same mistake. Barium is Ba, and it's in family 2. So it's a metal, which means it's a plus. And if it's a metal, its charge is equal to its family number, 2. Then hydroxide, it's a polyatomic ion from that list over there. So I'll go ahead and put my hydroxide as OH-. And then, just like the last one, I need to balance. This does not equal 0, so I do have to do the drop and swap. So BaOH2. But I don't have 2 H's, I have 2 OH's. BaOH2. That sound isn't annoying at all. I'm so glad I don't teach downstairs, though. This would be a nightmare right now. No, you don't have to put any charges after you're done. They're moving the big, heavy ones. Those like big square tables in the science rooms, or the bio rooms. Okay, this one, most people had it right. Most people that had it wrong just didn't have parentheses. Do you understand? Tell your lab partner real quick if you understand why the parentheses are there. Ready, go. All right, so now we're on potassium hydrogen carbonate. If you're like first hour, no one will get this one right. A couple people did, though. Potassium is not a P. I don't know if anyone in this hour did that, but it's a K. Potassium hydrogen carbonate. This thing is a polyatomic ion that we are supposed to have memorized. It's on there, right over there. It is HCO3. Then, potassium is in family 1, which means it's a metal, so it's a plus, and it's a 1. Metals are equal to the positive charge of the family they are in. Unless they're transition metals, then they can vary. All right, and then HCO3 from memory is a -1. Now, if you're stuck with HCO3 and you don't know, but you do know that CO3 equals a -2, an H is a +1 always. So +1 minus 2, that's why it became a -1. All right, now I'm going to get rid of that. If these already equal 0, what do I do? Rhymes with muffin. Thank you. Nothing. All right, it's already done. KHCO3. Potassium, hydrogen, carbonate. Rarely does it just 100% tell you everything, but it did in that one. Okay? Next one. Oh, right there. Sodium sulphite. If it's ITE, that means it's a polyatomic ion. So sodium is Na. Sulphite is SO3. That's a memorized thing from that page right there. All right, Na's in family 1, so it's a positive 1. Sulphite should be memorized. It's a negative 2. Drop and swap, Na2, SO3. Do I need parentheses and a 1 right here? No. You can put that, but you'll just look like you don't know what you're doing. All right? If the thing's written, it's already at least there once. We don't need parentheses unless we need more than one of it. Okay, if you're like first hour, a lot of you got that one right. All right, our last one. Go ahead. Nope, because the Na is only one thing. Now, I can put it, but then once again, you'll just look like you don't really know what you're doing. But it's not wrong. You just don't need to do it. Okay, the last one, magnesium fluoride. If it ends with IDE, it's just the element, unless it's on that list over there, like hydroxide. So magnesium fluoride is Mg. Fluoride is just the element of F. And then I just find the charges. Magnesium's in family 2. So it is a +2. Fluorine is in family 7, which means it's 1 away from 8. So it gains 1, which is a -1. MgF2. Good. I love positive. I don't get that very often in AP. So whenever you feel good about something, say it out loud. That makes me feel happy. Okay. Yes, question. Shh. Let's draw this out real fast. Yeah. Let's add this in case you don't have this in your notes. And it's really hard to draw perfect on this slate, so just bear with me. Yeah, it's okay. This is family 1. It's just easier right now to just draw them with the normal number. Okay. So this is how it works. And we have our little staircase through here, right? All right. Family 1s are always +1s every time. Family 2s are always +2s. Family 3s that are metals are +3s. Boron never does really anything, so just you don't need to stress too much about that. All right? Yep. And then family 4, we don't really deal with it much either. It's plus or minus 4. And it depends on where it's at. If it's up here, it's a plus or a minus. If it's down here, it's a plus. But you don't need to stress about that much. Let me put the lines in here. We need to know about 5, 6, and 7, though, for sure. All right, so first off, we never do anything with family 8 because the noble gases don't do anything. So now, here, instead of losing, these gain. So now we become negative, and they gain 3 to get to 8. So all of these are -3s. Now, these have to gain 2 to get to 8. These have to gain 1 to get to 8. Does that sort of make sense? Okay. Oh, you're good. Now, these are your transition metals. I need to redo that. Transition metals really are all of these. And their charges are variable. And they kind of annoy kids at first, but most of them by the end like it. Because if it's a varied charge, I have to tell you what the charge is, which means you don't have to think. Because it's written right there in Roman numeral. So these are actually kind of nice. Now, I do need to tell you, there are 3 elements that are transition metals that do have specific charges. They are zinc, cadmium, and silver. And these will drive you nuts because they don't have a Roman numeral and they're not in one of those families. Both zinc and cadmium are +2 ions, and silver is a +1 ion. You definitely want to put those in your notes. Correct. Yep. All right, so chromium 4 oxide. Give this a shot. This one I ask on purpose because it has one little trick at the end. I'll give you 1 minute. 1 minute to do this. All right, here we go. Shh, back with me. So chromium is what symbol? Cr. What does this Roman numeral mean? It means it's a 4. That's what it means. Makes it easier, huh? All right, then oxide. If it's IDE, it just means the element, unless it's an ide on that list. So we have O. And then what's oxide's charge? -2. Now, most kids will just drop and swap and move on. They'll put a 2 and a 4. And this is wrong, because there was that one little sliver of notes that said if these are divisible by the same number, you need to reduce them. So it's technically CrO2. Who had that right? How many reduced? 1, 2, 3, 4, 5, 6. How many had it non-reduced? 7. Thank you. Only 1, 2, 3. Okay. Now, this is not a hard mistake. We just needed to remind you that it is an option. Make sure if these two numbers are divisible by a number, reduce them. Okay, next. Zinc oxalate. That's the chart, or that's the formula of oxalate. My first hour let me know I did not have you memorize that one. So, nope. That would seem to make sense. A polyatomic ion is written how it is. And look, this is going to be tricky. Do you see how these are both nonmetals? Never reduce nonmetals. You only reduce it when we're doing ionic compounds. So the end of this chapter is all about naming two nonmetals or binary compounds, and we'll learn about that. But don't ever reduce your polyatomic ions. But your overall ionic formula, yes, you do need to reduce. Good point, though. All right. Oxalate. Well, what's the charge of zinc? +2. And then oxalate, C2O4. And what's its charge? -2. If these already equal 0, what do you do? Nothing. ZnC2O4. Who had that right? Okay, we're getting closer. We're getting closer. Okay, calcium dihydrogen phosphate. Calcium dihydrogen phosphate. Ready, go. So let's work through this one together. So calcium is Ca. It's in family 2, so +2. And then dihydrogen phosphate from this list, and if you're watching the video, I'm just looking at the list that's on the web page. All right, calcium dihydrogen phosphate. You can use just your knowledge of chemistry to sound this one out. Di means 2 hydrogens. Phosphate is PO4. And then typically PO4 is a -3, right? But each H we add reduces it, or actually whatever. Math-wise, it's kind of confusing to say that. So now this is just a -1. Then drop and swap. I do need more than one of the polyatomic ions, so 2. CaH2PO4 2. Raise your hands if you had that one right. Oh my. Oh my. Fantastic. Oh my. Oh my. Okay. Now. Right. Correct. Where's the page I want you to go to? Uh-oh. Everyone's going to grab an iPad now. I don't even know where it's at. Just grab an iPad and log into Canvas. The screen just for 30 seconds, and it'll be a lot easier to explain. Once you log into Canvas, maybe. All right. In Canvas, you're going to Chapter 2's page. And then it's just this naming practice right here, which really should be formula writing practice. Whatever. You click on that, and then you have 20 questions. Now, I'm not going to have you do the 20 questions. I'm going to have you work till 9:35. Some of them, it asks you for the name. You don't know how to do that yet. You can try and figure it out because it's not too hard. But just work for a nice solid 10 minutes, 8 minutes it looks like, and see how you do. All right, solid sodium carbonate decomposes into sodium oxide and carbon dioxide when heated. So you have to write out the formulas and then balance. And we don't know how to balance yet, but we will by the time we take this exam, which is probably the end of this week. All right, so it says solid sodium carbonate, so I have to find the formula for that. Sodium is Na. We know carbonate by now. CO3, good job, Newman. And what's its charge? -2. All right, what's sodium in family 1? +1. So it's Na2CO3. Then decomposes means I just put an arrow, and then I have to find the formula of these. So sodium oxide, it's Na and O, +1 -2, Na2O. Plus carbon dioxide is just something you should have memorized. We'll learn tomorrow how to write the formulas for those. They're pretty easy. Is CO2. And then you would balance. What's that? Well, when you do 2 nonmetals, we do not do the charges. Now this one does balance, but most of them don't. And we'll learn that. So this is the goal. It's to be able to write a formula from a written equation. And then you have to balance it. Yes, this one's already balanced, Caleb. Oh, I thought you were. All right. So anyway, that's the plan. Okay, tomorrow, we'll have 2 minutes, but this is where we're going to go tomorrow. So inorganic nomenclature now is the reverse. It's taking the formula and writing out the name. And it's super not that hard. Shh, it's still my time. It says write the name of the cation. So that's your metal. So like, and I'll just do a simple one here. If you had ALN, Allen. So the name of the cation is just aluminum. All right? And then, if the anion is an element, is this an element? Yeah. Just write it ending in IDE. That's all that's saying. It's not that bad, right? If it's a polyatomic ion, like this would be, and then write the name of that. Nitrate. All right? Now, the complicated part, and we'll go over this first thing tomorrow, is if the metal can have more than one charge. So one of those transition metals. We'll teach you how to do that. And it's not fun, but it's not impossible either. Okay, you guys were awesome today. Make sure your iPads are away.